Welcome back. I want to look at PDF files, and I want to write a Python script that can obtain information from these PDF files and returns the total number of times a search term appears in a document. And I also want to obtain the page numbers where a particular search term appears. Now, in practice, this is a very frequent problem which you encounter when you want to construct measures of good or bad corporate governance. As an example, I have here a financial statement which was published by Marks & Spencer, a retail company, in 2019. Now, when you have a PDF document, of course, what you can do is you can manually collect information. Yeah. So we could, for instance, look at audit. Yeah. So we could, or we can look at auditor, and we would be able to find the number of occurrences just by doing a manual search using Control F in the PDF document. Of course, that is maybe an acceptable process if you have a handful of PDF documents. However, if you have hundreds of them, maybe thousands of them, it becomes really very cumbersome. So can we use Python to make this a lot more fun? Yeah. So the idea is we want Python to do this work for us. Yeah. So please open a PDF file for us, look for certain terms, count the number of occurrences. We want to have all the occurrences in the document, and we want to know on which page does this term appear. So that's the task. Let's get into it. So how do we fix it? So let me first talk about my Python setup. Yeah, let me close the PDF file. In my case, I run Python in Sublime. So well, that's my text editor to be precise, and I execute using the command line. You might have a different setup. For instance, you might use Anaconda, you might use then Spider or Jupyter as IDE, which is perfectly fine. The thing we have to do is we have to install, if you haven't done so, a package which we need to work with, which is PyPDF2. So that's the one we have to install. So either you have to do it through Anaconda, or you have to use then the pip installer to do that. If you have any questions about how to install PyPDF2, just leave a comment below and I will get back to you. But you find all this quite easily in the online documentation. Alright. Now, before we go any further, I just want to note that all the codes, all the material is available on GitHub, and I leave down below in the description a link to the GitHub folder for this particular problem. Okay, now let's get into this in a bit more detail. Now, let me just open up my command prompt. So in here, I just type in cmd, and I'm just in the right location, and at the moment I don't have any virtual environment activated. Now, personally, when I do some professional work, I would strongly advise you to do this in a virtual environment, in particular if you have to install some packages that sometimes can get a little bit tricky, because some of them have, of course, dependencies and so on. So to get a virtual environment, what I have done is I just put in here virtual env for environment, and then I named it as PDF. Yeah, so and I executed that. I already have created that. So if you haven't done this, I would recommend you create a virtual environment using virtual env command, and you can name it. If you haven't installed virtual environments yet, again, you have to do this using the pip installer. You don't have to have a virtual environment, okay? That's not really needed. It's just a lot safer, to be honest. Yeah? And it's much easier later to obtain requirements and, you know, to make sure that someone else using your code knows what you actually what you need to do to run your code. So I already have done this. And you see now in my folder that we have a subfolder PDF, yeah, and you see the subfolder scripts. The only thing I have to do now is I have to activate my virtual environment, which I do as follows. I refer to my current directory, and then I go into PDF. I go into scripts, and then I go into activate. Yeah, this will look a bit different if you are on a Mac operating system. Yeah, so now it's activated, and you see now the name of my virtual environment popping up inside the brackets, and I'm ready to go. Okay, good. Now I move back to Sublime. So I import PyPDF2. I will also import already RE. RE is an amazing module for matching of strings. It contains many useful functions. So RE, I believe, refers to regular expression syntax. Again, you can correct me if I'm wrong down in the comments. I'm usually wrong most of the time. But I think it refers to regular expressions. There is a lot to say about it. Again, we don't have really the time here, but if you want to know more, just drop a comment. Okay. Now, first things first, I want to assign now my file. Yeah. Of course, this could be not just one file, it could be many files you have in a folder. Then, of course, you have to modify a bit the way you code. So in my case, I just have one sample file. I just call this file underscore name using lower snake case, and then I refer to the file name, which I believe is MS 2019, and then PDF is the extension. Yeah, so that's MS for Marks and Spencer, and 2019 is the year. Then you could start a document. Document is just the name I use for the object. It's a doc object. I call this a document object. But basically what I now do is I refer to my PyPDF2 module, and I basically take this file and I take this and assign it to doc, and this gives me my PDF object. Yeah, and this is using PDF file reader, and now I have to pass in the file name. So it might be useful just to check you know, what is going on here, just to do a type function on this object, because we don't really know it yet. Of course, what you can always do is you check the online documentation, and let me just run this now, Python, and I use here py.py, oops, not PyPDF, funny. Here we go. And you see now popping up the class PyPDF2 PDF file reader. Okay, so it seems to have worked up to this point. Good, so what can we do with it? And of course now you have to really go into the documentation, which I have done, to know what you can do on this doc object. Okay, so what do we need? First, what we would like to have is the number of pages. Yeah, because that's helpful if you want to write a loop command. We have to know yeah, how many pages are there. So let's do that. I just call this here pages, and I refer to doc, do the dot operator, and you already see the first one here. It's get num pages, and I just open close brackets. So I execute this method. So that should give me the number of pages. Again, it might be useful maybe to do a little print and just, you know, check whether it's still all up and running as expected. So you run it one more time and we get 65. Okay, that's promising. So now we have the total number of pages. I just remove that. The next thing I would like is I want to specify the search term, and in here I call this search, which might not be the best name. It might be also a function, you never know. But let's call this search, or maybe search term might be better. Let's leave it there. Let's see what happens. And I go into, say, independent. Yeah, let's do this. Independent. Yeah, my spelling is always terrible. It doesn't matter in my case what language I use. Spelling is always awful. The best thing is just to use numbers. Okay, so here we are. So now what we want to do is we want to look for the term independent, looking at this PDF file, and of course you should use your own file for that and see what happens, whether we can actually find it. Okay, now what do we want to get out of it? So I want to have something in return. So when I execute my script, what I want is I want to have a total number of occurrences, and I would also like to know how many times the search term appears on each page, and I would like to have the page number as well. So how can I package this? I could imagine returning a list. Yeah, I always like lists. It's easy to work with, so we can have a list. We can, of course, inside the list have other lists, but personally I quite like to have a tuple in between. So a list of tuples, because I don't want to change the structure of a tuple. Now what does this tuple do? It gives me all occurrences, and it also refers to the respective page number. Yeah, so this is basically what the list of tuples does. I start building it up here, so I just say list, and that's pages, and I start with an empty list, so open, close, rectangular bracket, so you get an empty list, and later I want to put in the tuples which give me the occurrences, all occurrences on the respective page. Yeah, so that's the idea. Good. Okay. Right. Now, well, I want to now go through this document. Yeah, so how do I do it? I use a for loop. That's the obvious thing to do. I call the respective page number, the respective page I. So for I, we go in range, and this would now start running from 0, and it goes up to the number of pages. So it's pages here, and we shouldn't forget the colon here. I go into indentation. I'm inside the block. And now I have to again check the documentation and see exactly what I need to extract the text from the PDF. And what works in this case is you have to do this page by page, and this is why we do the loop over the pages. And basically what we need to do first is we have to basically obtain an object based on the current page. Yeah. And I just call this here the current page. So what it does is it basically takes the whole document, and now page by page we throw the information into the current page object, and then on that object we try to extract the text, and then we do some matching. So that's the idea. Good. How do we do it? We refer to our document, which we already have done before. And I now want to focus on a particular page, and I just use get page and refer to that page, and I just use, of course, now my index I here. Yeah, so I go through all the pages up to the maximum number of pages, and I put the information from the document to my current page. This is what you have to have in mind. And then I obtain the text from my current page using the dot operator. So, and here we extract text. Yeah, extract text. Again, you have to, of course, check exactly the documentation to know these things, because, well, you wouldn't, except you actually wrote this yourself. Good, so that's a method which we call on my current page, and that should actually do it. So now we have the text, hopefully. Yeah. So that is interesting. We could maybe just try, for the fun of it, how this looks like. I have no idea. I haven't tried this really before. I don't want to do it for all the pages. I just want to do it maybe for a couple of pages or something. So we just change the range now. It's just for testing. Let's just do that and see what happens. Yeah, so actually this is what you get. So you get indeed now the text popping up. So it's reading through this document. Yeah, so that looks promising, and that's just for the first pages. Yeah, so that's all it is. Yeah, so that looks promising. So we get basically text out of it. Yeah, and so we can do some string matching on it. Yeah, so it's always nice in between to use some print functions just to see, you know, what is happening here. Because to be honest, in Python, because it's dynamically typed, you never know, you know, what object you get. You should always check, and in particular if you work with some you know, modules you haven't worked before, so it's always good to check the documentation and do a few, you know, print statements. Good. So now I want to use the RE package to do some string matching. Now, if you do the following, so this is RE, and you use find all. Find all is exactly what we are looking for, because we want to have all occurrences, not only the first occurrence. But again, it depends on your problem. It depends what you're looking for. So usually for my type of work, it's useful to have all occurrences. So I use the find all. And then I have to refer to, in the argument, I have to refer to the search term, which is search, and where I look, which is text. Yeah, so that's it. Now, this here, and again, this is in the documentation, will only return something if you find something. Yeah, if it doesn't find anything, it will be simply it will be nothing returned. Yeah, so if we want to look for the cases where you actually find the word at least once, we can do this in an if statement. Yeah, so we will only execute if it's found, otherwise it will be just not found, and it would not go into this if statement. So if we maybe do first another print just to check how it looks like. Let's do that. I just copy paste that and just do a print statement. Yeah. So again, the logic is now we actually go back to pages. The logic is we go through all the pages up to the maximum number of pages. We take the page from our document, our complete document, pass it on to our current page document, and then we extract from this object the text, which we already know is text, so that should be fine for string matching. Then we use the find all, which comes from the RE module, which gives me all the occurrences, and that only shows me something if it's found. Yeah, so let's have a look how that looks like. Okay, that looks promising. So what you see is you get a list. And this list has here only one element, and sometimes it might have more, has two elements. Yeah, so obviously you get a list. So that also means if I use here the len function, I would get the number of elements contained in that particular list, and this gives me the number of occurrences on the page. Yeah, which is the first thing I would like to have. Yeah, so in here what I could do then is I could simply do the following: get rid of print and use len. So do the len function, which gives me the number of elements contained, and this would be the number the number of my counts. Yeah, so I just use count pages here. So count on page might be maybe nicer to write you can modify this, of course. So this would give me the number of occurrences on a particular page. Yeah, so that would be exactly what I want. And then I want to modify my list underscore pages. So this is the empty list, just appending the information. And again, I want to have the structure you see above. Yeah, all occurrences, which is simply that's count page. And then the second element in this tuple would be the page number. Yeah, and I have to be, of course, careful that I put also enough brackets in, because we have a tuple. Yeah, the page number here is I. That's the index I use in this for loop. Yeah, so this should give me an appended list page which contains the tuple that provides the total number of occurrences and the respective page. Okay. Oh, yeah, I forgot one bracket. Yeah, that's it. Good, so that's the trouble. I forgot one bracket and things are getting a little bit funny, but now we are back on track. So here we are. Let me just run this one more time. It's running through. Let me maybe just now, after exercising that, do a print function and look at list pages and just see what we obtain. So this is here our result basically. Let's do that. Let's run this one more time. So what do we get out of it? Here we are. So we have here one occurrence on page 0, one occurrence on page 2, two occurrences on page 29, and one occurrence on page 30. Now that's pretty cool. Yeah. So it's working as you would expect. Yeah. So that's quite nice. So we have now actually all the stuff we need. The only thing we could now do as well is we could think about, you know, combining everything into a total word count if we want, and we might also like to count all the pages that you find the result on. So we can of course now modify things as we want. So I just do the following. I say here number of pages that contain the search term at least once. Yeah, so we can ask that, which would be simply a count. I just call this count, again a len function, and I would just look at the whole list and just count how many of these tuples do I have. Yeah, so that would give me the number of pages that contain the search term at least once. Okay, so I might like to know this. Then we can also do, of course, something like the total word count. Yeah, so again, if this is what we are interested in, I just do it here. We just do total. So what we need to do here is we have to basically do the following. So I just maybe do it step by step. So we do, I think the best is we do a list comprehension here. So we know we have a list of tuples, but now we just want to have the number of occurrences. So this is tuple position 0. So I do something like this, tuple for tuple. And I index, I use 0, so I look at the first position inside the tuple that gives me the number of occurrences, and then I run through for tuple in list pages. Okay, I explain that now in a minute. So this is called a list comprehension. I obtain a new list. Yeah, so you see here we have a notation for list. So we have rectangular brackets. I start reading here. So for the tuple inside my list pages, I put into my new list the tuple position 0. Yeah, so I should get a new list where I only have the occurrences but not the page numbers. Yeah. So if we run this, we should total should be now a list. Yeah, so if we run this, let's see what happens if I didn't make any stupid mistake. Most likely I do make a stupid mistake, but here we are. Okay, so it's running through. Of course I don't have a print statement, so silly me. Let's do a print statement here and do it one more time. And here we are. Here we are. Yeah, and you see we have the original, our original list of tuples, and then I only take the first one of each tuple, and I get this resulting list. Yeah. So now we have a list, a normal list, and of course we can now use the sum function on that list to get the total number of occurrences. So that's the last thing we do. We just do here a sum statement. Yeah. So that's all we do, and now we have this nice combination of list comprehension and the sum function, and we are all done. Good. The last thing I would like is I use here a formatted string. So I put an F here, formatted string, and I would now give you the outcome. Yeah. So the word, and then I use here a placeholder, curly brackets. The word search, which is independent in our case, was, I might also inside the double quotation marks I can use single quotation marks. Okay, that works. So you have to be careful, you can't do double, you have to switch. So I want to have basically quotation marks for this search term. Was found, and now how many times, which is total. So total times on how many pages, on count pages. Yeah, so that is the stuff we return. Just save that for a second, and let me just run this one more time, and that should give me now the output I was looking for. Good. So the word independent was found 5 times on 4 pages. Here we are. So now we actually have all the stuff we need. We have a very neat way of looking for stuff, and of course now let's try something else. Yeah, let's do some very common word, and. Yeah, so how many times do I get and? Let's run this one more time. You know, doing it now manually becomes really painful. It's certainly possible, but quite painful. Yeah, here it takes a few seconds. So here you have all the occurrences. So the word and was found 1,310 times on 65 pages. Yeah, so every page. So of course, once you scale up and we have many PDF files, you know, this becomes fantastic to use compared to doing this by hand. Okay, so the last thing I want to do, and this is only if you're really interested, I want to refactor it. Yeah, so I want to tidy this up and move this actually into a function. Yeah, because I want to reuse it. Yeah, so now we do too much stuff manually, we do too much, you know, hard coding. I want to make it actually look a little bit nicer. Yeah, so that's the next step, which you might not like to take, but if you want, I show you now how to do this. If you want to refactor this. Good. So the first thing you note is in terms of arguments. So what are the arguments here? So what are the things you need to provide for this to work? We need the file name. You see that here, and we need the search term. Yeah, the rest should run through. Yeah, so these are the things I basically need. And then the thing is, what do you actually want to return? That's a good question. I would suggest the best thing to return, most likely, but this is entirely up to you, is to actually return maybe either the list, yeah, this list pages, or you might like to return the count and the total. Yeah, so I would leave it up to you what you prefer to return. Yeah, so it depends, of course, on your exact problem. But let me just do the following. I move everything here into a function. Yeah, so I mark all of that and use the tab. I move it all in, and I start here a function, and then I start tidy up a bit. Yeah, we don't yet know exactly what we want. I would. How do you want to call this? Maybe the word and page count function. Yeah, whatever you want to call it. Again, I use here lower snake case. What I pass in is I pass in here my file name. Yeah, you see that here. So I just anyway take that, I remove it. So that's the first thing I pass in. I will call the function later, so I just move it back down here. So we need file name in here, which is a string, so I can specify this. It's just sometimes nice to do. It's not necessary, okay, not necessary. And then we have a search term. Yeah, so again this we can move further down, so we do something like this. Okay, shift and tab, and we have here a search term, which again is a string as well. Okay, we don't specify any defaults. It's not necessarily massively relevant. And when we just look at this more carefully and go through this one more time, just think about the logic. And here we do a return statement. So what I want to return is total and count. Okay. And in the end, in here, I could then use this function and run it. Yeah, let's just do that. So further below, I just call the function. And let's do that. And we specify here a particular file name and a search term. So that is fine. That should do it. The thing, of course, that we could now, of course, call this maybe result or something. Otherwise, it gets quite long. And of course, now the result contains total as the first element of the tuple. So we would here not total. We would have here result 0, and we have then here result 1. Yeah. Again, if you have any questions on what I'm, doing here, let me know. So this is just normal refactoring. So make sure that. So here we basically apply. So this is the application, and of course you would usually move it into a different file, obviously, but we just keep it now in here just for testing. Good, let me just go through this one more time in terms of logic. So again, we specify now the word page count function. It takes file name, which is a string, and search. It then passes file name into the PDF file reader, which gives me this document, which I call doc. When I get the number of pages, I start creating my list of pages, which is a list of tuples that contains all occurrences and the respective page number. I go into the for loop through all the pages. I take each and every page into the current page. I extract the text. I use the if statement, find all, which returns anyway false if it's not found. If it is found, the find all will give me a list of all the occurrences. The len function will give me the number of times it appears on one page, which I call count page, not maybe the best name. And then I append the list with the tuple of all the occurrences on the respective page. I count the total number of pages, which are all the tuples in list pages, and then I obtain the total word count using this sum function on my list comprehension, and I return a tuple of total and count. Okay, so that's the idea, that's the logic. Isn't it beautiful? Let's run this, and most likely I just made a mistake. Yeah, so but that's the beauty of it. Let me try. Okay, we are done. So again, we see the word end was found 1310 times on 65 pages. Yeah. Now the beauty of refactoring is I can now just work with this. Yeah, I can simply work with that and modify it. Yeah. So for instance, what I can of course do now is I can just overwrite the result and change directly here the search term. But ideally, I would actually do it in the next lines. I do a new search term here. Above, we just do another search here, and I just do something like director. Yeah, and just run this and modify that, and basically let's see what happens. So I can modify it, I can run it several times, and I can reuse it. So we now have a nice function that provides the total occurrences and the pages where occurrences occur. So director was found 31 times on 11 pages. Now that's great. Now that's all for today. So I hope you had some fun. Let me know if you need anything else. And I see you next time with more problems around data wrangling. Yeah, so I hope you have some great data fun.